Hey everyone, welcome back to another Study Shed video. Today we'll be going over the topic of the alternating series error bound. So what is the alternating series error bound? So suppose we have an alternating series, the sum from n equals 0 to infinity of -1 to the n times a of n, where a of n is an arbitrary sequence. Now suppose we wanted to find the value of the series. Normally it is quite hard to find this value, so we would approximate it. But the question is, how do we make a good approximation? We use the alternating series error bound. It allows us to estimate the sum of an alternating series to a degree of error by using its partial sums. The theorem states that for a convergent series defined as the sum from n equals 0 to infinity of -1 to the n times a of n, with the sum s, the remainder between the sum and the nth partial sum is no less than the n plus 1th term of the sequence. Basically, the theorem is just stating that the series must be alternating and convergent, and because we know it's convergent, we know it has a real value for a sum, and thus we can assign it the value of a s. Shown above is the actual statement of the alternating series error bound, stating that the maximum error is the difference between the sum and the nth partial sum is less than the n plus 1 term of the sequence. Now let's move on to some example problems. Number 1. What is the error when approximating the sum of a series using the first two values? By the definition, the maximum error would be the n plus 1 term of the sequence. So in this case, it would be the third term. Number 2. What is the error when approximating the sum of a series using the first 19 values? Well, again, by the definition, the maximum error would be the n plus 1 term of the sequence, which would be 19 plus 1, or the 20th term. So what defines a good approximation? For an alternating series bound, the definition of good for our approximation is what we want it to be. For example, if we define good to be 1 over 10, we can use this theorem to find the number of terms that will produce a partial sum within or equal to 1/10 of the actual sum. However, if we define good to be 1 over 100,000, then we can still use the same theorem to find the number of terms needed to produce a partial sum with that error. Still don't understand it? Let's use a visual explanation. Suppose we want to approximate the sum using the third partial sum. Using our knowledge of series, we can claim that the fourth partial sum equals the third partial sum plus the fourth term. Our visual shows a few partial sums. We see that the distance between the third and fourth partial sums is equal to the fourth term of the sequence. And since the series converges, by the alternating series test, we know that the absolute value of the terms are decreasing. Therefore, we can conclude the partial sums approach S. Also note that the distance from the third partial sum to the fourth partial sum is less than the distance from the third partial sum to the actual sum. And earlier we stated that the distance from the third partial sum to the fourth partial sum is just the fourth term of the sequence. Therefore, we can state that the distance from the third partial sum to the actual sum is less than the fourth term of the sequence. And this can be generalized for all n. So we can state that the distance from the nth partial sum to the nth plus 1 partial sum is just the nth plus 1th term of the sequence. The distance from the nth partial sum to the actual sum is less than the distance from the nth partial sum to the nth plus 1 partial sum. So therefore, the error is less than the nth plus 1 term of the sequence. Earlier, we did some example problems to find the error when approximating a sum using a certain number of values. Now we'll be going over an example problem where we find the maximum error in approximating a series using a certain number of terms. So, example problem 3. Find the maximum error in approximating the sum from n equals 1 to infinity of -1 to the n plus 1 divided by n, using the first three terms. So we know the alternating series error bound, and we want to find the error after approximating the first three terms, meaning n equals 3. So by applying the above statement, we would like to find the fourth term of the sequence. By plugging n equals 4 to a of n, which is our sequence, we get a of 4 equals to 1/4. So now we know the maximum error is 1/4. And that concludes our video on the alternating series error bound. We hope you learned something new, strengthened the concept, or cleared up any confusion about this topic. Thank you all for watching, and we'll see you next time. Happy studying!